Welcome back, Algebra 2ers. We're going to be taking a look at the practice quiz for 8.1 and 8.2. A lot of the properties here I might speed through because you should have them somewhere in your notes, or I'm assuming that you understand what's going on. But if you get stuck, email me with a question, ask somebody, look through your notes. Chances are there's something there that would make whatever I'm explaining a lot easier. So I'm being asked to find the asymptotes for 1 over x minus 2 plus 1. I know that since I'm adding on an additional term here, this is going to shift your horizontal asymptote up 1 unit. So the horizontal asymptote is now y equals 1. And that's based off of this. I know that the vertical asymptote is going to be modified because of our denominator. So if I solve when x minus 2 equals 0, this is going to occur when x equals 2. Based off of the correct graph below, we're looking for the one that's going to show this graphed out. Well, I know that they alter this so that these are going in terms of 2. So some of these can be a little tricky to really see which one you want. I know that this one has a vertical asymptote when x equals 2, so this might be it. I know that the horizontal asymptote's also where y is 1, so I know that this one's going to work the best. I know that my branches are in the top right corner and the bottom left corner, so I know that this works because of the horizontal asymptotes. The domain is going to say that you want everything except where x equals 2. And I know that the range is going to skip over this horizontal asymptote here where y is 1. I'm done. I know that there are other parts to the problem here, but this one works the best because it applies the vertical asymptote, horizontal asymptote, and so that's problem 1. Let's keep it going for problem 2. Problem 2, they have you doing pretty much the same thing. Based off of what's going on here, I know that I'm going to have some modifications for our asymptotes. The equation I'm working with is 3 over x plus 4 minus 5. So I know that we're going to have a horizontal asymptote when y equals -5. And again, that's based off of this term at the way end. So that's where our horizontal asymptote is. Based off of the denominator, our vertical asymptote is where x equals -4. So I know those just based off of looking at the equation. If we had to narrow it down amongst all these, I know that it's not going to be b because of where the branches are in the top left and the bottom right. So that's only going to occur if the a term, meaning the term up here, is negative. But since it's +3, we keep it in the top right and the bottom left. So actually, the only option that makes sense here is going to be C. Be that. If you need the domain, you would say that the domain is where x cannot be equal to -4. The range is where y cannot be equal to -5. What I'm doing with the outside there is just brackets, but those are what you need. So that's problem 2. This next one has us giving a translation, so it's as if we're given the parent function 3 over x, and then we're being asked to modify this when we have the asymptotes where x is -2 and where y is 6. So I know that if our asymptote is where y equals 6, we can always sketch these out. So although this problem isn't asking you to sketch out what the equation looks like, you can totally do that. That might help you pinpoint exactly what you're working with. So this is talking about the horizontal asymptote. The vertical asymptote is where x is -2. And I'm sure that since the top term here is +3, it's going to behave in this manner. Although this isn't asked of you in the problem, you should start to realize what's going on here. So I know that I need to add on 6. So this isn't going to work. This isn't going to work because they're deducting 6. C and D might work. Remember, we want opposites for our vertical asymptote. So I know that if we're using opposites, C is actually the best bet. 3 over x plus 2, and then adding on an additional 6. That's what we want. So although this one's multiple choice, you should understand each little step of the process that took this further. So what's going to happen right here, we have the numerator and the denominator factored out, where we have x plus 3 multiplying with x minus 5. X minus 5 also appears in the denominator, and then we have x plus 4. So I know that based off of this, we're going to have a whole when x equals 5. And again, the reason this is because I see x minus 5 appear once, and then again in the denominator. So that's why I can say this. So I actually don't want to say that it's a vertical asymptote. I just want to focus on this part where x plus 4 equals 0. So we would say this part. So we have a vertical asymptote where x equals negative 4. I know that if this was all FOILed out, we would end up with an x squared term. So for the horizontal asymptote part, this would get you something like x squared minus 2x minus 15. And that's all over x squared. And again, I'm doing this because I want to look for where the exponents are going to be the highest. So the leading term, that's what you're aiming for here with the horizontal asymptote. So I see that the exponents are the same. So since the top equals the bottom, this falls back on the properties that you saw in the 8.2 video. So since the top equals the bottom, we just use our coefficients here of 1 over 1. So we're just focusing on coefficients. One is actually going to be our horizontal asymptote. So I know that, again, because of the exponents that are pieced together. I know that my vertical asymptote is negative 4. I know that my whole is when x equals 5. And I think that's all you have to find here is the holes and the vertical asymptotes. So that's what you need. This one's going to be really easy because if we look closely, we have x squared plus 3 dividing with 14x squared minus 5. I know that the top equals the bottom. And again, we're talking about the horizontal asymptote. So that's where you have to do a little bit more legwork to figure out exactly what's going on. So if we look at our exponents, the top is equal to the bottom. So we use coefficients. So the top coefficient here is 1. So we have 1 dividing by this 14 here because that's the bottom coefficient for x squared. And this gives us our horizontal asymptote of 1/14. And we're done. This might not always be the scenario. You have to fall back on those cases and know when they're applied and how they work. So keep those in mind. I know that right off the bat for problem 6, I should really factor everything I can. That's always a good sign that you know what you're doing. So if I were to factor the denominator, I could say that this is really x plus 2, x plus 3, And then x plus 2 again. You should notice consistencies here with x plus 2. So this is going to allow us to say that our points of discontinuity are going to be both of these. And eventually we'll see what we do when there's a hole. But for now, we just want to say that our points of discontinuity are going to be the opposite of 2, so negative 2, and negative 3. Since we are talking about when they're removable or non-removable, whenever there's a hole, so let's also write that. So since we have a hole, when there's a hole for one of our points of discontinuity, we say that it's removable. And if it's not a hole, then it's non-removable. So since x plus 2 repeats, this is a non-removable, or sorry, this is removable. So this is a removable point. Whereas if there's no hole for one of the points, we would say that it's non-removable. We have to hold on to it. We treat it like a normal asymptote. So that's what we'll say for this. Simplified point of discontinuity to just POD because I want to preserve my markers and I'm running short on time. So that's why I did that. I think that's all that's asked on this one. We'll keep it going. For the vertical asymptote on this one, I know that this is going to revolve heavily around the denominator. There are no holes here, so that's good. So you would just set x plus 6 equal to 0, x equals negative 6. So that would be your vertical asymptote there. For the denominator here, I've been seeing a few students get this tripped up with how it can be rewritten. It does seem odd to have the x term way over here and not in the front. So you may want to rewrite that. I factored the denominator because there was a trinomial and it's an easy one to factor. So for the numerator, we can definitely try and map this out or try to factor it a little bit further, even though it seems weird to do that. So I know 3 and 15 share a common factor of 3. Since this is negative, I'm going to pull out negative 3. So as we take this further, we want to acknowledge that there's going to be a hole when x is 3. Sorry, when x is 5, there's a hole. So there's a hole. What else are they asking for? X and y intercepts determine discontinuity is removable, non-removable. So since x equals 5 as a whole, we would say that this is removable. And since x equals 3 is not a whole, we say that's non-removable. They also ask for the x-intercepts and the y-intercepts. There's going to be none. So there are no x-intercepts because we would have to fall back on what the numerator is saying. But since x minus 5 is a whole, it's just going to be an open circle there. So we actually just say that there's no x-intercept. But for the y-intercept, if we plug in accordingly, we would end up with something along the lines of 15 over 15, which is just 1. So the y-intercept here is going to be 1. Your x-intercept, there's none because there's a hole. For the domain, you would say that you exclude 3 and 5. I don't think they ask about the range. That makes our life easy. I think this has everything you're looking for. So that's good. So let's see, where are we? We're approaching the last few. Might speed run through this. Hopefully this has been helpful so far. For horizontal asymptotes, again, this falls heavily on the exponents. So here, our exponents are equal, so the top equals the bottom. So we take our coefficients of 28 over 7. So we say that there's a horizontal asymptote where y equals 4. And you want to type an equation here, so make sure you do that. For this bottom bit here, determine where there are holes, if any, of the function x and x repeats. So there's a hole when x equals 0. What else? Vertical asymptotes. When x is 5, that's a horizontal asymptote. Yeah, that's it. So this one's actually pretty simple. So, sorry, I'll make this look like a 0, not a 6. There you go. All right, so that's it. I hope this video was helpful. Thank you for those students who mentioned that they would benefit from this. Hopefully it was good and you took away something, or you just feel more confident about your work. If you're still a little unsure on something, look back through your notes, practice this again and again, look back at all the practice we've done. There's a lot there, so really make sure you utilize it. Thanks for watching. And I don't need this anymore.